So, hello everyone. That's the XenStore. My name is Filipe Manco. I work for NEC Europe. This work was done in collaboration with Lupo, that is over there, from University of Bucharest, and also Florian, that is joining us tomorrow, also from NEC. So, why, in case this works. So, why do we want to kill the XenStore? To understand that, it's useful if I talk a little bit about why do we care and what do we do. So we do work a little bit with, or a lot actually, with Unikernels. Maybe some of you know the ClickOS Unikernel. That is basically a port of the Click modular router to MiniOS. There is also this one called Minicache, that is a content cache for the edge, so it's basically a web server and the content cache on top of MiniOS, also developed by us. And so we have other unikernels, we're still working on unikernels. And what for? So one of the things is microservices with VMs. So when you have microservices, you can imagine that you stop having VMs with names that should be run forever. You start having VMs that are much more volatile, that appear and disappear much faster. You also have more VMs. Also, when you do per-user virtualized services, you can think about something like a virtual CPE, a customer premises equipment, and you can think about deploying one of these per customer. So you're going to have a lot of VMs running. We also work on more hardware-constrained devices, like ARM boards, to deploy these kind of things in the edge. So that is also important. So that means that in terms of what we need, there are two base things. One of them is performance. So we need low boot times because you're going to have a lot of VMs being created and destroyed. You're going to need also a good scalability because you want to have a lot of VMs running and you want to consolidate as much as possible. And of course, you want low overhead. The second thing is that we don't really care about all the functionality that Xen provides. So we basically only use PV or PVH guests. We don't care about QEMU. We don't care about full virtualization. We usually only need VIFs. Sometimes we need block devices, for instance, for the content cache. And basically, we only care about the features that we need for a certain use case. So we don't need to keep legacy stuff or backwards compatibility. So with that in mind, what is wrong with the XenStore? So the first thing that is wrong with the XenStore is actually performance. Some of you may remember I was at the Xen Summit back in 2014 presenting our initial results of our tests of Xen scalability. And already at the time, the XenStore wasn't one of the biggest contributors to increase, for instance, domain creation time when you have a lot of VMs in the system. And although it got really improved, mostly with the Xen 4.8 release that improved the XenStore D, that is still the case. So this graph is basically a breakdown of the domain creation time. This is done by instrumenting Excel and by aggregating different pieces of the process into certain categories. And you see that the green part of the graph shows the time that the Excel spends interacting with the XenStore. So that is clear the biggest contributor, and it scales super linearly. So it's a big problem. The second one is the device creation. And actually on our breakdown, we didn't separate in the device creation part, the parts that interact with the XenStore. So actually that device creation there also includes some XenStore interactions. So the XenStore is clearly a problem in terms of scalability, mostly when you want low boot times. So the second thing is the protocol. And it's actually one of the reasons why the XenStore becomes a performance problem. So the protocol is too generic. It basically requires you dozens of messages to create a single domain because you need to write this entry, write that other entry, write that other entry. And each of these messages requires you to write to a ring, kick an event channel, then on the other side it needs to be received, message processed, write the answer, kick the event channel again, and so on and so forth, dozens of times. So that is less than optimal. The XenStore protocol also limits the directory size because there's a limited size for the message. and all VMs will have an entry under local domain. So it's not a hard limitation for the number of VMs you can have. You can still create more than, you can actually scale to thousands of VMs. But certain operations might start to fail, like for instance XenStore LS, XenStore LS. Searches are also very expensive. So for you to have an idea, when I did my test with Xen 4.4, after a few thousand VMs, more than 80% of the time to create a domain was spent just looking if the domain name already existed on the XenStore or not. That's more than 80% of the time. So it is also a centralized service, which means that, of course, it might be a problem in terms of performance, but it also becomes a centralized point of failure. And if you want to do that, it also makes it harder to make the DOM0 rebootable, which might be a problem. The other thing is something that we actually don't care too much about, but we know it might be important for the Xen community because of the work directions that some people here are taking. That is certification. The XenStore is one more piece of the system that you need to certify, and we think it's not really necessary. So what can we do? We could create a new protocol, make it easier to create domains. For instance, you can think about creating a domain from a template, so it requires only one message. Same for devices, so that's an idea. You could improve the implementation. You could parallelize, for instance, the XenStore implementation so that it scales better with more VMs. There is work that was done on the old XenStore D, I think, on Xen 4.8, and I've just read that on Xen 4.9, I think it was also improved. There is the transaction handling mechanism. So for 4.8 for old XenStore D, and for 4.9, I think it was improved on XenStore D. So there is also another thing that we can do, and it's being done, and it gives really good results. It really improves the scalability. We did also try to implement a XenStore version, a C++ XenStore version, also focused on performance. And we released it open source, it's available on GitHub in case you want to check. We can add new functionality. We can think about having, for instance, two XenStores running at the same time, so that if one fails, the other one takes over. It's not trivial to implement, but maybe it's possible. We can think about implementing persistency. So I think there is actually a old XenStore D version that has persistency implemented, not the upstream one though. So if you have all of these, you're going to end up with a better XenStore implementation. But there's still some problems to solve. It's still a centralized service. It probably still becomes a performance bottleneck depending on the boot times that you want to have and the number of VMs you have in the system. So we started to think, why not just kill it? Why do you actually need the XenStore? So that's when we started to think about NoX, the no XenStore system. And to define what you want with NoX, it's useful to understand first what is the XenStore used for? What are the XenStore features that what is the XenStore used for, and what are the features that we actually care about? So one of the things the XenStore is used for is to keep basic domain information, for instance, the name of the domain, and that's functionality we really don't care about. So it is also used, for instance, for CPU hot plugging. That is something that we don't use that often, but is probably important functionality that we should keep. Setting up of the ballooning is also done through the XenStore, which, again, same story, is not something that we use so much, but we probably want to keep that as well. It's used to keep tool stack related information. Mostly we use our own tool stack, not Excel, and we really don't have the necessity to do this, so we don't need this. The most important thing we have on the XenStore, at least for us, again, is the setup of virtual devices, so the Xen bus. So that's fundamental. Power control is also done through the XenStore. That's how you do suspends, that's how you do power-offs, and that's very important if you want to migrate your domains. So we should keep this functionality. And the last thing is guest-specific functionality. For instance, ClickOS uses the XenStore to read router information. If I remember correctly from the Mirage guys, the G2 paper, they were using it to advertise service endpoints, for instance. But this is a functionality that we don't care to keep in our no-XenStore system. So in terms of goals, we have basically two main features. One is the Xen bus, and the other one is what we call guest control. And you'll see that actually our NOC system is basically a replacement for the Xen bus, and we implement then the other one in a different way that I'll show later. So also we want the NOX to be a simple mechanism because we want it to be fast and because we want it to be simple to implement, so few lines of code, efficient, scales good. We don't want it to be based on a centralized daemon. And finally, we probably think that it should run side by side with the XenStore if we decide to do that, if you want it to be adopted, right? It's probably not the greatest idea to just kill the XenStore. So we basically designed our NOX system based on this. And again, our NOX, what we call NOX, is basically a Xen bus replacement. So this is the basic architecture. There's a lot of boxes, so let me go one by one. So the major idea of NOX is you have a shared info page, you have a star info page. If you want to have to give a device list to the guest, why don't you create a device info page? So that's what we did. Basically, in NOX, you have a device info page that is maintained by Xen that contains basically a list of devices that are available to the guest. That device information page is, again, maintained by Xen, and it can be controlled by the tool stack by a new hypercall called devctl. So the idea here is that you keep all of this information in Xen that is already centralized, so if Xen dies, we're fine. Well, we're not fine, but there's no other centralized point introduced here. And then we introduced this hypercall so that Xen can keep track of this page and manage this page itself. So this is what device information page looks like. I'm not sure you can see the code from the back, but basically what it has is basically a version number so that you can upgrade this later if you want. And basically the important thing is here an array of devices. And the devices look like this. They have a type, so is it a VIF or a block? An ID for identification, and then these three pieces of information. That is the backend ID, a grunt, and an event channel. So these three pieces of information are then used to set up what we call the device control page. So the device control page, and also an associated event channel, is basically the mechanism that we use to then initialize and control the device. And basically is a mechanism that allows the backend and the front end to communicate. So this device control page will basically have all the information that you previously would find on the XenStore. So this is an example for the network devices. You find in the control page basically, basically event channel information, the ring references, IPs, bridges, multi-queue information, all that kind of stuff that previously you had on the XenStore now goes into the device control page. And it also has information about the backend state, front-end state, watches. The idea here is you could implement these whatever you want, but we try to implement this in such a way that it doesn't disrupt too much the state machine of the backends, so that it's kind of easier to implement in such a way that is compatible with the XenStore. But again, this page can be however you like. So with the NOX system, this is what it looks like to create a new domain. So these are, of course, only the differences that you have by using NOX. So when the tool stack tells Xen to create a new domain, of course, all the normal things are going to happen, and then the Xen will basically allocate another page and initialize. That's going to be the device information page, and then it's going to share that page read-only with the guest. Then basically, and that's the only difference in terms of the initialization of a domain. So then the tool stack needs to, per device, communicate with the backend and say, I need a new device of this type to this DOM ID. The backend will basically then allocate and initialize the device control page, grant it to that guest, and also allocate a new event channel for that guest as well, and return the grant and event channel information to the tool stack. And then is the responsibility of the tool stack, by using the new devctl hypercall, to tell Xen, please update the device information page and add this new information to the device information page of a certain guest. And that's about it. In terms of the initialization from the part of the guest, also these are only the differences, but basically what happens is the guest, when it comes up, it basically, using the devctl hypercall as well, asks the hypervisor, what is my dev IP? And the hypervisor gives it an MFN that it can then map in the system. So we did it like this because we wanted, again, to keep compatibility with guests that don't know what NoX is. So this way, if the guest doesn't know what NoX is, he's not going to do the hypercall, and everything will just continue normally. Of course, if you have the XenStore running. In case the guest knows what NoX is, it then does the hypercall, gets the MFN, and then it can basically process the information in that MFN, check the grunts, check the event channels, map the grunts, and bind the event channels, and it has the communication channel open with the backend. So there's only two more things I want to talk about this diagram. One other thing is all of these NoX modules. In terms of implementation, we decided to do it like this because basically we wanted to have on DOM0 a NoX module that keeps communication channels open with the different backends that might be running in subdomains. That is faster because the NoX module in DOM0 will basically keep those communication channels open, and that way the tool stack, when it needs to create a new device, it doesn't need to open those communication channels over and over again. It just needs to do a high OCTL to the module in DOM0, and then that module will know what backend it should communicate with and ask for the creation of the device. The NoX module in the guest will be then the responsible for doing the devctl hypercall and mapping the page, and then enumerating the devices and telling the backends you should initialize this device and that device. So the other thing is the tool stack, that of course needs to be different. And that XenDevD box over there. So before you had hotplug scripts that of course rely on the XenStore to get some information and to put some information. We had this daemon called XenDevD that we created to make the hotplug scripts faster, basically. So it's basically a binary that runs, listens for UDev events, and then does what the hotplug scripts would do before. The only catch here is that we actually have the tool stack communicating with the XenDevD when we want to set up a block device. To ask XenDevD to set up, for instance, the loop devices, give the information of the major and minor numbers basically to the tool stack, so that then that information can be sent to the backend. So this is the basic structure of NoX, so the XenBus replacement. I also talked about guest control. And that's still important. The way we implemented that is basically through a GCTL device. So it's basically a virtual device using the split driver model. Everything is the same. That basically implements these features of, or will implement these features of power control, CPU out plugging, and it can be extended later. So there's nothing very special about this, but just for you to have an idea, suspending a device domain using this new device basically requires you to do a high OCTL, tell the backend, please suspend this device. The backend will then just write, I want to power off, the reason is suspend, in the device control page, kick the event channel. That's going to be noticed by the front end. They will notice I want to suspend, so I want to write an acknowledge on the page, kick the event channel again. The backend will check the acknowledge, tell the tool stack everything is okay, and then the process is the same. The tool stack just needs to wait that the domain actually suspends. So what is implemented already? So we implemented the basic mechanism, so the device information page, the devctl hypercall, so all of the basic mechanism. We implemented support on Linux for the network device and the block device, and we also implemented the GCTL only for power control currently. And in terms of the tool stack support, we did implement it on our own tool stack called Chaos. Chaos is our kind of toy tool stack. It's also available open source. We did implement it on Chaos because it's much simpler than Excel and libxl. Also, it doesn't have all the functionality that Excel and libxl has. That's why it's much simpler. And it's much easier for us to develop new features, not just Nox, on this tool stack. So if you want to check it out, it's also available on GitHub. I also said that it's important that the code is simple. So this is basically a stat for our current patch for Xen. And it basically shows there's basically 550 different lines of code. The Xen mechanism is quite simple. It's basically just allocate an extra page and initialize it. Then the devctl hypercall is also pretty basic and straightforward to implement. So the patch here is very small, actually. On the Linux case, not so much. There's like 10,000 lines of code different. The reason for this is that we implemented this in such a way that it is compatible with the XenStore. So we added Nox functionality, but the Nox-enabled modules are still able to boot using the XenStore or Nox and initialize devices, actually, one device from the XenStore, the other one from Nox at the same time. If we are to remove XenStore support completely from the modules, then we believe actually we would reduce the number of lines of code because the Nox mechanism is slightly simpler to implement than the XenStore one. Conversely, what is missing? So one of the things we would like to have is crash recovery and device hot plugging. So they are basically the same thing in the sense that what you need is a way to tell the guest, hey, look, your device information page changed, so you need to do something about it. It could be your device information page changed, there's a new device, so you need to initialize it. There's one less device that was removed, or the backend crashed, so you should reset your device and reinitialize it. So that's a functionality we'd like to have, but it's not supported yet in the design that we have. We need to think about how we could do this. It could be done, for instance, using an extra event channel to notify the guest of changes, but we need to think about how to lock the page, basically, because we can't allow the guest to be reading the page while we're modifying it. So it's a feature that needs to be designed. We did not implement stub domain support yet, so actually the modules cannot be on stub domains, the backends cannot be on stub domains yet, and we also didn't implement serial console drivers for Linux. In terms of the GCTL device, CPU, hot plugging, and ballooning is not there yet. And in terms of tool stack support, as I said, Excel and libxl don't have these yet. For these features, there's nothing fundamentally wrong. It's just that we didn't have the need or the time to implement them yet, but it should be straightforward to implement. So finally, and this is going to be my last slide, I just want to show you a performance analysis of a NOX system. This graph basically shows you the domain boot times, a comparison of the domain boot times for when you use Xen 4.8 standard, and our tool stack Chaos with Nox implemented. So this is a logarithmic scale. So this actually scales super linearly. And this is the number, the line for the standard Xen. It goes from up to, for the 1000th VM, it goes for roughly 600 milliseconds. This is a very small VM. It's a mini OS running with 8 megs of RAM, if I'm not mistaken, 1 vCPU and 1 VIF. Whereas our number remains almost constant. It grows a little bit, but actually most of the increase in the boot time there comes from the VIF creation in the kernel. So actually the Xen-related parts, the Nox parts, are almost constant for up to 1,000 VMs in the same system. Okay, that was all.
Hi. When you designed the architecture of it, did you consider the possibility that 2 agents in the guest might want to talk independently to it so that you wouldn't have to have a single daemon to multiplex or communications to? Because that's one of the issues with XenStore, is that it's very difficult to have more than one thing talking over XenBus to the thing in DOM0. So something like a bootloader architecture, which runs over a PV SCSI device or something, is very hard to implement because it has to hand forward the handles to the next part of the operating system.
I'm not sure I understood the question.
So in the XenStore architecture on XenBus, it's necessary to hand forward all the handles that have been opened from a bootloader to the operating system. So it's very hard to do that for, say, a Windows domain, because there isn't really a mechanism for doing that. In your architecture, is that something that's easier to do?
So the idea here is that when the domain boots, all the information needs to be on the device IP already. So the backends need to be set up. They should have granted the pages already to the guests, the event channels as well. So in principle, yes, you could just, all you have to do from the guest point of view is basically to read the device information page that you should be able to request from the hypervisor, and then basically map those pages and bind the event channels, and that should be all set up before. Again, we wanted to have these hot plugging of devices, but that's an extra feature that actually is not available yet.
So I have two questions. The first one is about the structure of your device control page, the per device page. Yeah, if you get that one. So I see you've basically just laid out a struct in memory like that. Binary protocols like this can be awkward to extend, and I don't see much of a facility in there for future protocol extension. One of the things that the existing XenStore arrangements do is they make it easy to add new features to this later. Have you thought about that at all?
Yeah, I just noticed it's actually not on this struct. Again, this is not the actual code, just a simplified version. But if you look, for instance, at this one, the idea is that you have a version there. There always needs to be the first field in the struct, so it always is at a defined location, so that the guest and also Xen knows what is the version of this device information page, and how it needs to behave. So this can be extended by just increasing that version number there. And of course, the guest will then need to support the different version numbers. That would be the same for the device control page over there. It's not there, but it would need to be.
Well, just a moment. If you just have a version number field, then you can't advertise the new version to the guest unless you know the guest supports it. So there's no facility for negotiation there, the way that we have at the moment, where you can, the host can offer the guest, you know, what features it would like.
Yeah, that is true. That would need to be advertised somehow in the guest image. So when you boot the guest, you would need to know what the version is.
Right.
That it supports.
I mean, if we go back to what James was saying, that's not really, that the guest might use different versions of the driver at different times. As James, for example, points out, it might have a bootloader followed by an actual operating system.
That is true. So for the dev information page, again, well, if you have different versions of the drivers, then you basically need to use the minimum version that is supported by all of them, right? But again, no, we didn't thought about that
So
protocol exchange. It can be implemented, I think. For instance, if you have the version there, maybe you can, the first thing you do before you initialize the page is you advertise or you ask the guests to write a version number there, and then based on that, and kick the event channel, and based on that, then you
Right.
initialize the page the correct way.
Yeah,
that could be done.
I mean, I think this is a complicated topic. I have some experience in it. If you want to talk about this offline, it'll going to get very complicated. But there are ways of doing this. You might consider, I know this may seem like a strange thing to do, but you might consider using a textual format for this information. Mm-hmm. It makes it more difficult to update it in place, but on the other hand, textual formats are much easier to extend in a forwards and backwards compatible way.
Yeah. So the other thing we could do actually is, this is the way we implemented it, because in our use case, this information is static, we don't have those problems with versions, but you could think about also a message passing protocol here. We don't want one that is as complex, let's say, as the XenStore, but it could be done as well. So it doesn't have to be a static structure. It can be a message passing protocol.
I think maybe somebody else should have a go, even though I have a second question.
So we'll get back to key value pair eventually if we keep going. Anybody else?
As you noticed, there has been a lot of improvements in Xen 4.8 and Xen 4.9 with particularly improvements in transaction handling in XenStore. Do you have equivalent graphs for that? Your performance graph was what, Xen 4.8?
4.8. So Xen 4.8 with XenStore. No, it was Xen 4.8 with XenStore. Because the Xen, as far as I know, if I'm not mistaken, the XenStore, the XenStore version was improved in Xen 4.8. So we actually made sure that we were using the most recent version of XenStore D. Also, I don't have graphs here, but I did test the two versions of XenStore D, one before Xen 4.8 and one after Xen 4.8, and that the improvements are quite evident. It was greatly improved by the improvement in the transaction handling algorithm. But the thing is, it still increases the domain creation time with the number of VMs, which I think it's kind of obvious because basically the backend database size is going to increase. It implies searches in the XenStore. So I think it's quite obvious that it needs to increase. But I agree with you that the performance got much better. Yeah.
Okay, I think we've got time for one more.
Well, it's more of a response to James that we don't need to pass any handles from the bootloader to the kernel about XenStore or anything like that. In fact, we already have something like pvgrab that opens XenStore, opens the block device, parses the kernel, and hands it, well, and boots the kernel. So that's not really a problem with XenStore.
Okay, I think we're done.
Thank you.